This is the video for accelerated geometry on section 9-2 on sampling distributions. Key vocabulary in this lesson is simple random sample, systematic sample, stratified sample, cluster sample, convenience sample, self-selected sample, a probability sample, margin of error. The essential question is, how do you estimate population means and proportions and develop margin of error from simulations involving a random sampling? To start, there are 6 different types of sampling. The first one is simple random sample. Members are chosen using a method that gives everyone an equally likely chance of being selected. So the easiest way to think of this is pulling names from a hat, using a calculator to randomly generate numbers, to use a computer to randomly generate numbers, and so forth. A systematic is when members are chosen using a pattern. It's also known as using a rule. So, for example, you decide you're going to select every other person, every 10th person, every 50th person, everybody with a red shirt. You have some type of rule in place that you're using in order to pick your sample. A stratified sample is when the population is first divided into groups. Then members are randomly chosen from each group. Okay, so you divide them into group and then randomly pick people from each group. A cluster sample is when the population is divided into groups and then the sample is choosing one or more of the groups and you survey everybody within that group. So the difference between stratified and cluster is that in a stratified, somebody from each different group that you've divided the population into is picked, where in a cluster, it's you're dividing them and then picking an entire group. Convenient sampling is when members are chosen because it's easily accessible, meaning like if I was doing a survey on favorite flavors of ice cream and I worked at an ice cream store, I would just ask people as they came into the store. A self-selected sample is when members volunteer to participate. So the easiest way to think of this is like these days, just about anywhere you go, at the bottom of a receipt, there's a phone number to call, there's a website to go to for you to fill out a survey. And anytime you do that, you're becoming part of the self-selected sample because you're volunteering to be part of the sample. The campaign staff for a state politician wants to know how voters in a state feel about a number of issues. Classify each of the samplings. So number 1 says they call every 50th person on a list registered to vote in the state. So because there is a rule in place, this would be considered a systematic sample. Example 2 says they randomly select 100 voters from each county to call. So the key part here is that they're calling from each county. So first, the state is divided into counties, so you're dividing the population into groups. And then you're randomly selecting people from each of the groups. So this would be an example of stratified. Number 3 says they ask every person who comes to the next campaign rally to fill out a survey. So because they're just asking people, whoever ends up coming to the rally, this would be considered a convenient sample. Example 4 says the editor of a snowboarding magazine wants to know the reader's favorite places to snowboard. The latest issue of the magazine included a survey, and 238 readers completed and returned the survey. So this is an example of self-selected because a person had to first buy the magazine, then they had to actually fill out the survey, and then actually mail it back. So the person is choosing to be part of the sample. A probability sample is a sample where every member of the population being sampled has a non-zero probability of being selected. So basically it's saying that every member of the population can be selected. Simple random samples, stratified samples, and cluster samples are all examples of a probability sampling. A convenience sample is not a probability sample because people in the population who are not convenient for the surveyor to survey have no chance of being surveyed. Self-selected samples is also not a probability sample because the members of the population that don't self-select themselves have no chance of being surveyed. So whenever we're trying to decide whether something is most accurate, very accurate, or not accurate, your most accurate form of doing a survey is going to be to do a census because remember that is surveying the entire population. Very accurate methods to get samples is using a simple random sample, a stratified sample, and a clustered sample. And not very accurate methods are convenience samples and self-selected samples. Example 5 says a small town newspaper wants to report on public opinion about the new city hall building. Classify each sampling method, which is the most accurate, which is the most least accurate, and explain your reasoning. So method A says that they just ask readers to write in and give their opinion. So because they're just asking people to do it and mail it in, then this would be an example of self-selected. Method B says they survey 10 randomly selected female students and 10 randomly selected male students in the cafeteria during the lunch period. So because they're asking people in a very specific spot, it's easily able to be accessed. This is an example of convenience. Method C says they randomly choose 10 streets in a town and survey everyone who lives on the street. So you're first divided into groups, the streets, and then they're surveying everybody within that group, which is everybody that lives on that street. So this would be an example of cluster. So we have that method A is self-selected, method B is a convenience, and method C is a cluster. When we start talking about what was the least accurate versus the most accurate, method A is going to be your least accurate because only people who are willing to volunteer their opinions are the ones that are going to be chosen. Method B is also inaccurate because only students and only those in the cafeteria are the ones that are going to be surveyed. And method C is the most accurate because different groups are randomly chosen and then all the members within that group are chosen. The margin of error of a random sample defines an interval centered on the sample percent in which the population percent is most likely to lie. So for example, a polling organization that surveys 1,000 voters in a city to find out how they plan to vote in an upcoming election. The organization reports that 58% of the city residents plan to vote for Smith, and the survey has a margin of error plus or minus 3%. This means that the percent of voters in the population who plan to vote for Smith is likely to lie within 3 percentage points of 58. That is, that it is likely that between 55% and 61% of the voters plan to vote for Smith. Now, how did we get the 55 and the 61? We took the 58, subtracted 3, that gave me 55, and took the 58 and added 3, and that's what gave me 61. Example 6 says a survey of random sample of voters shows that 38% of the voters plan to vote for Thompson, 31% of voters plan to vote for Chang, and 31% of the voters for Harris. The survey has a margin of error plus or minus 3%. Does the survey clearly project the outcome of the voting? Explain. So the first thing we're going to do here is we're going to find our true intervals. So we're going to first start with Thompson. And we would have the 38% and add or subtract the 3%. So 38 minus 3 gives me 35%. And 38 plus 3 gives me 41%. Now Chang and Harris both have the same. So if we take their 31% and add and subtract 3%, 31 minus 3 would leave me with 28%. And 31 plus 3 gives me 34%. Now, because this Thompson's interval does not overlap with Chang's and Harris's interval, we can say that yes, the survey clearly projects the outcome of the voting. So to put that in a sentence, we can say, yes, while there is an overlap between the intervals for Chang and Harris, their intervals, which are from 28% to 34%, do not overlap the interval for Thompson, which is 35% to 41%. Last example says that a city is about to hold an election. According to a survey of random sample of city voters, 42% of the voters plan to vote for Poe, and 58% of the voters plan to vote for Nigel. The survey's margin of error is plus or minus 7%. Does the survey clearly project the outcome of the voting? So again, we're going to start with Poe, and we're going to take the 42% and add and subtract our margin of error. So 42 minus 7 would give me 35%, and 42 plus 7 would give me 49%. Then we're going to do the same thing for Nigel. So we have his 58% plus or minus 7%. So 58 minus 7 would give me 51. And 58 plus 7 would give me 65. So again, the two intervals do not overlap, so our answer would be yes, there is a clear projection for the outcome. So again, to put this in a sentence form, we could say that between 35% and 40% of all voters plan to vote for Poe, and between 51% and 65% of all voters plan to vote for Nigel. Because the intervals do not overlap, the survey does clearly project the outcome of the voting.